subtopic number 4, which is on electromotive force, internal resistance, and potential difference. So in this subtopic, you should be able to define what is EMF, internal resistance of a battery, state factors that influence internal resistance, describe the relationships between EMF of a battery and potential difference across the battery terminals, and lastly, use terminal voltage. Okay, so EMF versus potential difference. So terminal voltage is the potential difference across the terminal of a battery when there is a current flowing through it. EMF, on the other hand, is the EMF of a battery is the maximum potential difference when it is not connected to a circuit. Okay, so battery, it has its own EMF. Untuk potential difference pula, it only applies when there is an electric current flowing through the circuit. Okay, so EMF here is basically defined as the energy provided by this cell here. Okay, and then terminal voltage pula, it is the work done in bringing a test charge from the negative terminal to the positive terminal of the battery. Okay, all right, so let's consider this. I actually should have said that here, but it's okay. So let's consider this circuit, which consists of a cell connected by wires to an external resistor. Okay, so a current will basically flow from the positive terminal to the negative terminal here. So for the current to flow continuously, an EMF is required. So that is the battery. So the battery is used to maintain the potential difference between point A and B. Okay, and EMF is defined as the energy provided by the battery. Okay, and then the potential difference pula, it is defined as the work done in bringing a charge from the negative to the positive terminal of the battery through the external resistance. Okay, so the unit for both is volt, and when the current flows naturally from the battery, there will be an internal drop. Why is there an internal drop? Is because there is an internal resistance. Okay, so the terminal potential difference can then be equal to the one shown here. Okay, so it will not be equal because there is a internal resistance in the battery. Okay, so the EMF can then be calculated using this formula here. Boleh? So IR here is the internal drop in potential difference, or also known as VR, small r. Okay, right. So this equation here is only valid if the battery supplied to the current is where the potential difference is less than the EMF. Okay, it's only valid that way. Okay, so for the battery without internal resistance, obviously the voltage will be equal to the EMF of the battery. Okay, this is for the case when in the cell there is a internal resistance. Okay, all right, now internal resistance of a battery. Okay, so internal resistance of a battery, which is R, it is defined as the resistance of the chemicals inside the cell. Okay, and it is calculated by using this equation here. Okay, this is only when the battery is used lah. Okay, when the battery is used, baru dia ada internal resistance lah. Okay, so the potential difference across, this is a potential difference across internal resistance, and then I is the current in circuit. Okay, the value of the internal resistance depends on the type of chemical material in the battery, and then the symbol of EMF and internal resistance in an electrical circuit are drawn this way. Okay. Okay, boleh faham? Right, I think yes, that is the theory part for subtopic 3.4. So what you need to know is how to use this equation here, and that is gonna be in the next video lah, which is on the examples.